Perfect. So hello everyone. Welcome to Copenhagen Developers Festival and welcome to my session, Why Verifiable Credentials and Decentralized Identity. It's a pleasure for me to be here. That's my first time presenting here. I hope that you will enjoy the session. And a small disclaimer, I would like you to know that this is not like a deep dive session when it comes to verifiable credentials. It's more about some concepts, about understanding why we even have this topic, like verifiable credentials and decentralized identity, and why it's needed. Obviously, I have some practical demos, and I would like to show you something in practice, so I will not only present slides. However, the purpose of this session is more to understand some concepts, why we have this discussion even, why it's worth to know more about decentralized identity and verifiable credentials, and why potentially that's the future. Even if we don't agree and we like current state of the, I would say, identity world, it will change. Everything is changing in the technology, the same is with identity. So, before I will start, really quickly about me. So my name is Daniel, Daniel K. I will not pronounce my last name, it's tricky. I'm Modern Identity Lead at Formula 5 and Microsoft MVP. I also run my personal blog called TechMine Factory. I encourage you to visit. I'm trying to publish some interesting content there about Microsoft technologies, about DevSecOps, identity stuff, Azure Cloud development. And it will be the pleasure for me to connect with each of you. So if you would like to connect with me, here is the link, here is the QR code, you can scan it and let's connect on LinkedIn. And I'm really happy to be here and to talk about verifiable credentials and decentralized identity today, and I hope that you will enjoy this session. In the end, I also reserve some time for potential questions, and I promise I will answer them under condition that I have answer for you. I hope that you will enjoy. So let's start. Before we will even talk about decentralized identity, verifiable credentials, and things like this, I would like to a little bit more talk about the current state when it comes to identity world we know, which is the centralized identity and centralized identity systems, basically. So when it comes to centralized identity systems, probably you are quite familiar with that, with this topic, but we refer to the system where user identity, user data is collected, stored, managed, basically centrally by central authority that is called identity provider. And this identity provider can be Microsoft Entra ID, previously Azure AD, it can be Okta, it can be Auth0, it can be all other technology, basically. But the case is that user data and the identity is stored in the central place. And obviously, in this concept, we have all those different kinds of applications and resources that trust this central authority, yes, this identity provider. So we typically say that we secure our applications with some identity provider or providers. And obviously, in the end, we have users. Yes, like users that will sign in, or they sign in the applications to access specific resources. And once they are authenticated, they have access granted to those resources. And like this is a current state. Yes, we all know it. When we look at this simple diagram, there is user. Typically, there is identity provider, there is this login form. So even if you are not directly connected with identity stuff, if you do anything else, like you code, you do AI, you do DevSecOps, anything else, I'm pretty sure that you went through this flow at least once, obviously. You have your banking application, you have to register, you have to authenticate. You have Messenger to talk to your friends, or Facebook on the mobile device. You have to authenticate to even access the application functionalities. If you want to talk to different people on WhatsApp, then you have to authenticate using your phone number and some code. So it's even not about the username and password, because obviously you can say, hey Daniel, nowadays we have all different kinds of methods for authentication. But the case is that in general, there is some central place where we authenticate, we store credentials, information about the users. And once we do it, we have access to different kinds of applications and resources. And this is basically like typical architecture nowadays we have. It works, it has its advantages, and many people are familiar with that. Obviously, underneath we have different kinds of protocols, like OpenID Connect, OAuth, and so on and so forth, but still, it's about this schema. And in the end, when you think about centralized identity system and identity provider as a central authority, you know that there are users, user accounts are stored there are different kinds of applications that trust this identity provider. Again, there can be also different policies applied within this identity provider. An important fact is, and this is something what you see underneath here, is the fact that we can also build this trust relationship between different identity providers. And I'm pretty sure you also saw it somewhere, like when you have login page, you can use your username and password, let's say, but below you have those options like login with Facebook, login with Google, login with whatever, yes? So this is this trust relationship, also called federation, where different identity providers or centralized identity systems trust each other so we can authenticate and access different kinds of resources or applications. And that's great. That's what we know. And there's like a question, hey, why to change it? It's good, we know it, it works. It's fine, yes? And typically when I started, like diving into the topic of decentralized identity and verifiable credentials, I have a little bit doubts about it. And I was like, we have those protocols, we have those standards, yes. Everything is fine, we know this architecture well. Why to change it? Like, it's good. However, as everything, especially in technology and IT world, it has its own advantages and disadvantages, basically. And the same is with centralized identity systems, basically, in this case. So exactly the same thing, we have challenges. The first one, I would say, really the biggest one, is the fact that organizations store vast amount of user data, basically. And personal data, and it's left without the control of users, like totally out of control. Like, if you create a Facebook account, you have to provide all those details, first name, last name, address, all other details, and so on and so forth, and those details will land somewhere. And obviously you can say, hey, I'm owner. That's my data. I can always go to edit profile within the application and change it. But do you really own this data? Like, do you physically have it? That's the question here. Like, that's the challenge, because in the end you will realize that it's the data about you, but basically you are not the owner. When it comes to limitations, there is this trust boundary limitation. And that's about the federations. Yes, what I mentioned, like, it's not by default like all identity providers trust each other. We have to configure this trust relationship. It takes time, it requires some configuration. It's not like out of the box. And there are also some challenges related to that. And centralized identity systems also introduce the single point of failure. And I know that you can say that, hey, Daniel, we have cloud right now. High resiliency, availability, geo-replication, we are fine. It's not single point of failure. And as you probably remember some time ago, like a few years back, there was this huge outage of Facebook. Like, users couldn't sign in, they couldn't access their applications, profiles, they couldn't send messages, and so on. And it was exactly the same. Like, Facebook has huge infrastructure when it comes to identity. And all those other companies too. But the case is that still, when it comes to, like infrastructure, when it comes to data storage, or I would say, to be more precise, the storage where user data is stored, it's in the central place, even if it's geo-replicated. And one more thing, because there are many challenges, but one more thing is related to data breaches and security risk. Especially nowadays, like we hear, a data breach here, data breach there, and so on, like data leaked, and so on and so forth. And yeah, that's challenging, because when we look at those different kinds of solutions secured by centralized identity systems, sometimes it's just hard to make it secure. Like, even if you look at the current state of centralized identity systems, we talk about the MFA. We talk about step-up authentication. We have conditional access policies, yes, like to make even more secure those solutions. And the case is that obviously we have all those fancy things, but in the end, those are the challenges, yes? And as always, I could provide more and more and more, but that's not the case, because we want to talk about the centralized identity systems. But the reason why we have this discussion and why verifiable credentials are on the horizon and decentralized identity systems is the fact that people start realizing that, hey, those are real challenges. And we need something beyond that. We have to use something different to make sure that we can tackle those challenges. So before we will jump into specific topic related to the centralized identity systems, I would like to show you one thing when it comes to this concept, okay? So please see. This is the application, like some patient portal. And as you can see, that's the application. It's secured with identity provider. And basically, users can register themselves here, they can create accounts, and then they can access this specific application. So typical scenario we know nowadays. And obviously here, I have this temp mail, which I will use. So basically, I want to test registration flow. So I don't have account. I will create one now. So let me do it really quickly. Okay. I have to provide my email, so I will do it. I will copy it, as you can see. I will click next. Obviously, I have to verify this email address, so in a few seconds, I should receive verification code to my email. Hopefully, not to stay in silence too long. Yeah, and here I have the verification code. I can copy it, I can enter it. And then obviously, as in a typical example in the centralized identity systems, I'm asked for password, retype password, given name, surname. I can collect all different details, like I can ask for more, yes? So here, I will provide the password, I will retype it, I will provide the name, like this, okay? Let's use Daniel Tester, let's say, to make sure that we will defer this account. I accept privacy policy. I click next, and then obviously I can start using application. So my account is created, and in a few seconds I will have access, like error, obviously it happens, live demo. But when I refresh the page, hopefully you will see that I have access to this specific portal. And it doesn't matter what I have here. The case is that that's typical scenario. Like now I have access to this portal, I can do different things, and great. My account was created, perfect. And now what about the data, like where it landed, okay? So when I open the portal of identity provider, my goal is not to, like promote any specific technology. You will see this exactly in different kinds of identity providers. So it's not about Microsoft, you can use any identity provider, but it's more about the user data. So if I refresh this data, you will see that under users, my new account was created. So it means that obviously this information you can see here landed in a centralized place, okay? So obviously, I'm the provider of this data and owner. However, the data is stored somewhere else. And as you can see here, I have different fields. I have first name, last name. I can provide, as you can see, city, state, street address, zip code, and so on and so forth. And the problem is that still this data will land in the central place. And now, when you think about those challenges I mentioned, try to think about the situation where potentially I have some security issues with this solution, and anybody can access this user data here. So anybody can, like click all the users, can go to directory, can open Daniel Tester account, can go to my properties, get my, like street address, anything else, and so on and so forth. And then it becomes problematic, yes? And those are the real challenges I was talking about. Like, obviously, it's about the security within an organization or within the solution. But what about the situation when, like, potentially this data is leaked? Like, it happens, yes? So as you can see, yeah, that's a challenge. That's what I want you to remember about when it comes to centralized identity system, because now I will get back to presentation and we will start talking about decentralized identity systems and concepts and verifiable credentials, and you will see that it's quite different. So as you can see, I register my account, data is here in the cloud, and obviously as a user, I have a chance to update my profile, but still, to be honest, like I'm not like a full owner of this data. And different things can happen to this data, as I mentioned. Breaches, someone else from the organization can look into my data. That's challenging. So, because of this fact and those challenges, there was decentralized identity invented and the whole conversation about it, even before, like specific verifiable credentials implementations. But people, like started talking about different concepts and how to improve this solution and how to make sure that users can really own their data, yes? So in the decentralized identity systems, in this concept, identity holder has full control over and ownership of their data. So it's not like, oh, hey, I'm creating some account, I'm the owner, but data lands somewhere else. But I'm the full owner of this data, basically. And it basically, this provides privacy to users because they have a chance to decide which part of their identity they want to show. Like, for instance, they want to share information about their age, but maybe they don't want to share information about their address or anything else, yes? So in this specific scenario, you will see, I will talk about it when we will dive into verifiable credentials. That's different. In a typical centralized identity system scenarios, we share the data, it's there in the central store, and basically we don't have chance to decide like which data we want to share. Obviously, on the identity provider side, we can say like, okay, share only this data with applications, but it's nothing connected to decision on the user side. It's more about the identity provider configuration. There is no need to contact issuer. I will show you that in my diagram where I will explain how it works underneath. For now, just remember that when it comes to like communication in the decentralized identity systems, issuers that will issue credentials do not have to contact each other. And obviously underneath, we have cryptography and public key infrastructure. So it's about public keys, private keys, and digital signatures. So those are some basic concepts related to decentralized identity systems. So a few things. So decentralized identity allows people to have more control over their digital identities, yes, without relying on central authority system like identity provider. And that's basically important thing about decentralized identity systems. It's like, hey, we want to give the control over the data back to users so they can decide which data to share and where to store this data, basically. And in those systems, individuals can create, manage, like control their identities using different kinds of technologies. It can be distributed ledger, it can be blockchain, and obviously cryptography is engaged here. But important fact is that when it comes to infrastructure, it differs a little bit than a typical infrastructure in the centralized identity systems. Okay, perfect. So let's talk a little bit more about how it works, because I strongly believe that like some theory is great, and it's great to hear about like some concepts, why, pros and cons, and so on. But where is the meat? And let's talk about some specifics here, something tangible. So let's explain the concept of decentralized identity systems and verifiable credentials, and slowly we'll start diving into the concepts related to those terms. So as you can see here, we have Formula Health institution, we have another institution called Fabricam, and in the center of this whole solution, we have the user, and user owns digital wallet. It can be mobile application in this specific scenario. And underneath, as you can see, we have something what is called verifiable data registry or trust system. So typically when you will talk about verifiable credentials and decentralized identity, you will also see those terms like issuer, user, verifier, and verifiable data registries. And now obviously we want to see what's going on underneath here. Yes, like, okay, so how it works. So first of all, try to imagine the situation. Obviously, this is just a simple scenario to show you some concepts. And there can be many questions like how different things are handled in the reality. But I wanted to keep it simple, okay? So let's say that Formula Health is the institution where I can register as patient. And, you know, like I can do some surgery. And in the Fabricam institution, I can do some other, you know, like treatments, basically. So two different institutions. So first of all, when it comes to Formula Health institution, it publishes or stores its public key information in the verifiable data registry. Okay? So basically it stores information about its public key, which is used in the process of issuing a verifiable credential to specific user. So you can see that there is Daniel is patient, and Daniel is requesting patient credential from this specific institution. Okay, so please issue me verifiable credential with specific data. And now what will happen underneath, Formula Health, obviously in reality some identity verification will be done and so on and so forth. But important fact is that Formula Health will issue me the verifiable credential with some claims inside it, like with the information about the patient ID, information about my first name, last name, all other details, okay? And important fact is that there is also issuer, as you can see, so who is issuing this verifiable credential, and also we have issuer's digital signature. That's very important because we will see in the end how verifiable credential is verified. So now, as you can see, we are slowly starting understand that it's a little bit different, because in this scenario, it's not like I'm creating my account and I store my data somewhere. It's nothing like this. I store my verifiable credential in my digital wallet. So I have it on this device, and I will show you also today the specific implementation. But the case is that instead of storing this information in the cloud somewhere and so on, it lands in my digital wallet here, in my phone. And now, once I have it, of course, I can go to another institution, which is Fabricam, and I can say, hey guys, I want to do some treatment here, please register me, please verify me, I want to join. And they will ask, okay, so please present your verifiable credential issued by Formula Health. Please show that you did this surgery, let's say, at Formula Health Hospital, and then you can continue treatment in Fabricam. And what I can do, obviously Fabricam will ask me to present verifiable credential. So what I will do, and I will show you this process, I will present my verifiable credential that I have in my digital wallet. And once I present it, obviously there is like a decision whether I want to do it or not. But once I present it to the verifier, a verifier can look into those claims and, you know, like can verify that, okay, I have patient ID, I have first name, last name, and also I can see who is the issuer of this verifiable credential. Okay? So there is issuer's digital signature, but also the digital signature from my digital wallet. And now, obviously, Fabricam will look into the verifiable credential, will check the claims, but there will be question, but was this credential really issued by Formula Health? So it will look into the verifiable data registry or trust system and will retrieve information about the public key. Okay? I make it simple because I don't want to confuse you, but the case is that Fabricam can check the public key and then can check the digital signature on this verifiable credential. And this is the concept I was mentioning about the thing that we don't have to, that issuers don't have to contact each other, because as you can see, we have this verifiable data registry, and there is no direct connection between verifier and the issuer. So that's also about the decentralized identity systems. There is no federation. Like Fabricam doesn't have to go to Formula 5, register something somewhere, and so on. It can get information from the verifiable data registry, compare digital signature, check it, check the claims, and then it can move forward with other verifications. And obviously, there are a couple of things here which I want to describe. I don't have them on the slides because I want to also have this, I would say, conversation about it. There are a couple of things because, first of all, you have to remember that there is always question about those claims. Like, hey, someone or somebody is presenting verifiable credential, but can I really trust the data or claims inside this verifiable credential? So you can see I have this patient ID here, I have the name, cool. So I can set up some verifiable credential service, the centralized identity service, I can create such a patient credential, and I can go to Fabricam and say, hey, I'm the patient from Formula Health, everything is fine. So it's not so simple because around it, and obviously that's not the topic of today's conversation, but please remember that around verifiable credentials and decentralized identity, there are a lot of things around, like for instance, identity proofing, which is the verification of the user's identity. So even before I can get this verifiable credential, I have to present some kind of like ID to confirm that I'm really who I claim to be. So it's not so simple. I'm just presenting you the concept here, how it works when it comes to architecture and communication. But please remember that there are many things that have to be taken under consideration, including identity verification of the user, and also the thing related to issuer verification. So let's dive a little bit more into this, okay? So there are different kinds of components in the decentralized identity systems. I want to focus on 4 to make it simple, not to confuse you. So we have verifiable credentials, we have decentralized identifiers, we have DID documents, and we have distributed ledger technology. So this verifiable data registry I showed you underneath. One thing to remember, many people confuse this over the internet. When you say DID, it's not decentralized identity, it's decentralized identifier. So please remember about it because I had exactly the same problem. I was using DID and then somebody from the foundation told me like, hey Daniel, it's not about decentralized identity, it's about decentralized identifiers. So, verifiable credentials. We saw it on the diagram. It was issued to me as a patient, but what's going on here? So, what is it, like this verifiable credential? First of all, it contains information about the user, different claims about the user, like first name, last name. It can be, as you can see, patient ID, object ID, my photo. It can be full name, anything what you want, basically. So that's true. You can digitalize almost everything and put it into verifiable credential. So obviously there are different challenges, like it's not so simple to just put or convert your passport into verifiable credential. However, from the technical perspective, it's still doable. And by the way, probably you heard that European Union is working on verifiable credentials, and there is this EIDAS project also to make it possible for different countries in EU to communicate, to issue different documents and credentials, so different countries can verify this. Really, really cool project and a lot of different fancy things. And also credentials include identifier and metadata, basically to describe properties like issuer, I showed you that. So who issued this verifiable credential, but also expiry date, okay? So those credentials can expire. And credentials, a verifiable credential is a set of tamper-proof claims because basically it's signed, yes? So as you can see, as I showed you, we have this public key infrastructure involved here, so we can sign those credentials and then check the digital signature. And one more thing that is important is the fact that when it comes to what you can see here, the visual part of verifiable credentials, this is also something what you can configure. So it's in the standard. Like, we will talk about the standards a little bit later. But I can include logo. I can include information about the name of this verifiable credential. I can include the information about the issuer. I can change the color of this card. I will show you different cards in my digital wallet. But the case is that in the end, I get something like this in my digital wallet. So on my personal device. And now, when talking about decentralized identity systems components, we have decentralized identifiers, yes, and DID documents. And I promise I will try to keep it simple, and in the end we can also talk about it. But when it comes to decentralized identifiers, those are like simple text strings that consist of two things: DID URI scheme, identifier of the DID method, and DID specific identifier. And I know that that can be confusing, but think about this like currently about the domains and subdomains. Like you can type like www.xyz.com and then specific website will be displayed in the browser. Yeah? So the same is with decentralized identifiers and DID documents. So with decentralized identifiers, you can retrieve DID documents. So this analogy with providing the name of the domain and displaying the website, here you provide the centralized identifier and you retrieve the ID document. And now, as you can see, I have this verifiable credential here. I have this information about the issuer, and this is the DID document. And we will not study everything in this DID document, but I want to talk about a few things here. So first of all, this DID document contains information about the public key of the issuer, okay? So as you remember, let me move it like this. This is basically what is happening underneath when I'm presenting my verifiable credential to the Fabricam. Fabricam will look into verifiable data registry or trust system, will get the decentralized identifier and will use it to retrieve the ID document. We'll look then into the ID document to check the public key to verify the signature of the verifiable credential, but also it can look into different details included in this DID document. What are those details? For instance, linked domains. So that's about the security also, as you can see, because in the DID document we can include the information about the institution or organization or wherever it is, information about the domain. So when we are displaying verifiable credential to users, we can also display the domain that is connected to this specific issuer. So there are different things that can be included here, but I just want you to remember that every time you present verifiable credential, something like this is happening. So we are using the centralized identifier to retrieve the ID document, look into the DID document to check the public key, check the signature of verifiable credential, and check basically the issuer and the domain. Okay, let's move forward then. Distributed ledger technology. This can be really confusing because especially, I was the same. Really, I had the same situation. Every time we have this discussion about distributed ledger technology, we have blockchain in mind. Yes, like, okay, it's about the blockchain. Verifiable credential will land on blockchain, and then we can verify different things on blockchain and so on. Nothing like this, okay? So before I will jump into this topic, let me really quickly summarize. So distributed ledger technology refers to this decentralized database. And that's about the decentralized identity concepts, basically. So we have multiple participants from different locations, and it can simultaneously record different transactions in multiple places without need of the central authority. And that's really important fact here. So we have this distributed ledger, and there is no central authority that can say, hey, I own this. It's mine, and now you have to do exactly what I will tell you to do. And obviously, distributed ledger technology uses cryptography. So this is what I showed you with digital signatures. And blockchain is just one specific example of distributed ledger technology. So typically, yes, when you will hear about verifiable credentials, you will hear about blockchain. But I want to mention a few things here. Really important, because I'm trying to provide you as much details as I can so you can remember some concepts if potentially you decide to study this topic in the future. One confusion about verifiable credentials is that those credentials lands in this distributed ledger technology or on blockchain. No, that's not true. Like, really many people confuse other people saying that, hey, like, it's the centralized identity because those credentials will land on blockchain and then, you know, like, different people can access it. We don't have to contact issuer and so on. No. It doesn't work like this. In the distributed ledger technology, we store the centralized identifiers, we can store, and we can store the ID documents. However, when you will look into the specification for the centralized identity and verifiable credentials, you will see that it's not recommended to store any personal information within the distributed ledger technology. So many people, you know, like mix this, like for instance with NFTs or non-fungible tokens, where yes, in this concept we can store information in blockchain and there is some data stored there about the ownership, for instance. But with verifiable credentials, there is no other place than digital wallet. So in this specific case, my phone, for instance. Okay, perfect. So I think that we can move forward. I think that when it comes to verifiable credentials and where they land, I told you some of the things. I will tell more once we move forward. But there is one specific important thing about verifiable credentials when it comes to, you know, like the ownership of the data. It's called selective disclosure, okay? So with selective disclosure, user has the ability to share only specific data about himself, about, you know, like herself, basically. So we don't have to provide all the information about our profile. We can decide like, hey, potentially, I can provide my age without providing information about the date of birth or about my address. Or when it comes to, you know, like privacy-preserving transactions, financial transactions, I can only disclose necessary financial credentials without exposing unrelated personal information. And that's really important and powerful, because with this standard and this possibility when it comes to verifiable credentials and decentralized identity, as a user, I can decide which data I want to share. And today, we are missing this in centralized identity systems. Let me put a simple example, okay? I don't want to confuse anyone, so I will try to keep it simple. When you authenticate and you access application underneath in the centralized identity system, I mean, obviously application receives something what is called ID token, okay? Like token that can be decoded, and application can look into this token and can see information about the user, like user email, unique identifier, first name, last name, and obviously there is the signature too. So token can be verified. But the case is that there is no chance to give this ability to user to decide which data will be stored, will be shared. Obviously, you can say that, hey, there is this consent system in OAuth, like, hey, application would like to access your basic profile and so on, but that's something different. You know, like when you decide like, hey, okay, I want to grant application access to my basic profile even, it's not so granular because there is no option with consent system currently in the centralized identity to say, okay, share age with the application, but do not share my birthday and my email. Nothing like this. When we accept the basic profile, then application will get information about the basic user profile data. So that's also important. Okay, so a couple of things. So transforming physical credentials into digital ones offer this opportunity to make identity verification cheaper, more secure, more safer, basically, than the current like paper versions. Like even like with some documents on the paper, passports, IDs, and so on and so forth. And there is one more thing. With verifiable credentials, we can really digitalize those documents securely and on scale. Because someone can say like, hey, we have this digitalization. Like, I take a picture of your passport, I'm creating PDF, and I'm sending this PDF attached to my email to someone else in the office. Yeah, but this is not a secure way of doing things. And obviously, there are many different challenges when it comes to security. Someone can access this email. Someone can download your passport in PDF and can do different things with this. So if we want to talk about decentralized identity and basically document digitalization, verifiable credentials, this solution, is a good starting point, basically. And it really provides a secure way to share different kinds of data about users in a secure way. Okay, so that's about the theory. Obviously, I will get back to presentation, but I want to show you some concepts here. So a couple of things. Okay, we have TeamViewer. I install it just to show you. I will put it here. And yeah, sorry, I will get back here. I will log out from this application. And yeah, I want to sign out from this app. And now let me show you a couple of things here. Okay, that's not this. Yeah. Okay. Accept, allow. Okay. Hopefully you can see it. My face. Okay. So no, not this. Let me put it like this maybe, okay? So I will enlarge this because we have to get back to web application. So as you can see, this is my digital wallet. And again, I don't want to talk about specific technology. We will see it on slides. There are different implementations for a solution like this. I just want to focus on the concepts here, okay? So as you can see, I have my phone. That's mirroring from my phone. And I have different verifiable credentials here. I have verified driver credential. As you can see, it was issued by some institution. I have my data, driving license number here, different kinds of details about myself. I have verified employee, so in this case I can confirm that I work for Formula 5. Here is my corporate email, some details, my photo, and as you can see, it was issued by Formula 5 in this case. Again, it lands in my wallet. And eventually, as you can see, I have this verified patient credential. Okay? Obviously, it's fake, and you can say, hey, Daniel, like, I don't believe that in the reality it's so simple. It's not. It's not. But I'm just trying to show you different concepts so you can understand what you can do with this technology. So as you can see here, I have my first name, last name, national healthcare ID in the US, my photo, and some other details like my email and who issued this, like Formula Healthcare, as you can see, issued by. Okay. And now, obviously, what I can do, I can present this verifiable credential, but also I can get such verifiable credential. So I want to show you first the presentation process here. So what I will do, I will open this portal. Let me split it so you can see different things happening here. Okay, I have my phone here. please look, I'm typing my email address like this. And here, instead of providing password or any other details, I'm saying, hey, I want to use a verifiable credential. And now what I'm doing on my phone, as you can see, I'm scanning this QR code. And here, I'm asked whether I want to share this patient credential with this specific application or institution. And again, I can see all those credentials that will be shared. So now, if I click Next, I'm presenting my verifiable credential. Underneath, obviously, everything is happening what I showed you during the presentation, like the digital signature is checked, credentials, and so on. And I know that we see the error. I will have to investigate it, because you have to believe me that just right before the session, I faced some issues. But as you can see, if I refresh it, I can access the portal, and I don't have to present my credentials, okay? And that's the important thing. So in this specific scenario, you can see that I have this so-called hybrid mode. Like, I can use a centralized identity system, but also I use a verifiable credential and decentralized identity approach. So what I want to tell here during this presentation is the fact that you can either separate both concepts. Like, you can say, like, hey, we only use the centralized identity systems, we only use verifiable credentials, no centralized authority like identity provider. But the reality is that in many cases you will see both combined together. So they are not mutually exclusive. They can be basically used together, as I'm presenting this in this example. But the difference is that I have this decision where to store my data, whether I will store it on the identity provider side, so in centralized identity system, or I will store it in my wallet. If we get back to this application, I would like to also show you the issuance process, so you can see both, because now I presented it. But let me sign in with this previous account. Let's see, yeah, I can get my verifiable credential, perfect. And now what I will do, okay, I will get this. As you can see, QR code is displayed. And what I can basically do here, again, let me show you what's happening on my phone. I can scan this QR code. And now, here, I will be asked whether I want to receive this verifiable credential. Obviously, I have to provide this security code that is displayed in the application. Now, as you can see, I can get my verified patient credential. And if I decide that I want to receive it, it will land in my wallet. Important information is, as you can see at the top, there is also a verified domain. And this domain, again, is taken from the DID document that was retrieved from the trust system using decentralized identifier. So if I click Next, this verifiable credential will, again, land in my wallet, as you can see. So I have it, and now I can start using the application. And important thing is that I want to also talk a little bit more about this concept here. The important fact is that, the important fact is that how you include information in the verifiable credentials depends on your needs and the scenario. Because in this specific scenario, we are saying, hey, this institution will issue me verifiable credential, it will land in my wallet, but probably this institution also owns my data. However, in some situations, we can also create verifiable credential only with the data provided directly by the user. So user can go to the wallet, can type different kinds of claims, like first name, last name, and so on and so forth, create this verifiable credential, and it will purely land in the wallet without storing this information in any other place. That's very important. So when it comes to source of truth, when it comes to claims that we store in the verifiable credentials, obviously this can be taken from centralized authorities, this can be taken directly from the user, this can be taken from different kinds of tokens. So there are different ways to put credentials into verifiable credentials and create something like this you see here. Yeah, so it's important because some people think that, okay, so when it comes to the process, I don't have really decision how to, like include those credentials here. Nothing like this. There is like a full flexibility over the implementation, what you will include in this claim, and how then it will be verified. So that's what I wanted to mention. Okay, let me get back to presentation. Okay, so let's talk about some other examples here, because I think this can be also interesting. So in a typical scenario in the corporate world, but not only in the corporate world, like when we have a problem accessing our account or application, we typically call or contacting support. Yes, like, hey, I have problem, I cannot access my account. Okay, let me help you. What is the name of your dog? Where do you live? And so on. It's quite risky, yes, like especially nowadays with this whole thing about spoofing and so on. It's really serious. So instead of like doing different things around verification, we can basically use verifiable credentials. So in this specific scenario, a person from the help desk can generate such QR code, we can scan it, we can share our verifiable credential, and then a person can see like, okay, I see that this guy is from this organization, which is this issuer. Those are the claims like first name, last name, email, corporate ID, whatever. So now, once a verifiable credential is verified, I can update my password, yes, reset my password. So it's much safer than doing the typical scenario where we are calling someone, we are providing some different things over the phone. That's tricky. But it's not only about the corporate world, it's also about, like the typical, I would say, B2C world. That's another example, which is quite valid, I think. Let's talk a little bit more about it. So when you think about the car rental company, for instance, like the typical process is, okay, I can reserve the car, I have to provide my card. When I'm on site, I have to sign some documents, show my driving license, do some, like filling out some forms, and eventually I get the keys. And obviously, I have to do it at first time, which is also known as KYC, know your customer. So I have to provide my details so the company knows basically who I am and whether I have the driving license even. Because maybe I'm just I'm doing different things and I try to cheat. But the case is that once I'm verified, such car rental company can issue me the verifiable credential, which will land in my wallet. And the next time when I will want to rent this car, instead of filling out all those papers, I'm not talking about the driving license specifically here, okay? Let's think realistically. I'm not saying like, hey, let's put my driving license into verifiable credential, because there can be different issues, like for instance, maybe a policeman, has taken this driving license from me because I was speeding, or maybe I lost my driving license, or some other reasons, yes? But when it comes to filling out documents, like information about myself, confirmation, my residence, country, like my address, and so on and so forth, this can be taken from verifiable credentials, okay? So instead of filling out all those details and sending some scans, filling out forms on the websites, I can simply scan the QR code, as you saw, present my verifiable credential, and then I can be verified. So different scenarios here, really. And I know that at first glance, it looks like, hey, it's not so simple and there can be all other challenges. But the reality is that when you architect such process and you add identity proofing and all other things, then it really starting makes sense, and you will see the value behind decentralized identity and verifiable credentials. What about standards? Because beautiful visions, we saw it, it works, and that's cool. But what about standards? So exactly like in the centralized identity systems where we have standards, we have OAuth, we have OpenID Connect, SAML, all those different kinds of protocols, yes? Like we know how to implement identity. We know how to authenticate users, how to provide access to resources. We have ID tokens, access tokens, different kinds of things. The same is about the centralized identity. So, and the verifiable credentials. So there is OpenID Foundation here, which is responsible for standards implementation, like verifiable standards for presentation of verifiable credentials and issuance. You will see that under OpenID, you will find basically specifications. We have W3C, verifiable credentials data model. So the verifiable credential I showed you in the digital wallet, that was implementation of W3C verifiable credentials data model, like how it's displayed, the claims, the structure, and so on and so forth. Everything is based on a specific standard, specific model. And we have Decentralized Identity Foundation, so you know, like all those different concepts around distributed ledgers, decentralized identifiers, DID documents. This is also controlled by the Decentralized Identity Foundation. And I want you to understand that it's not also so beautiful, like everything right now is interconnected and it's so simple, you know, like to exchange verifiable credentials between different implementations. So it's called interoperability, yes? So that's why there is this Centralized Identity Foundation, because I would say it works, or it combines different organizations like Google, like Microsoft, like Okta, OutZero, and they are working together, all those smart people, to make sure that, if we have some different kinds of implementations, we can still, we have this interoperability. So if I have verifiable credential issued by one issuer with one solution, I can present this verifiable credential to another verifier, which is using another solution with verifiable credentials. So yes, there are standards underneath. It's not like a freestyle, nothing like this. There are standards. And when it comes to concrete implementations, you will see that more and more solutions become available on the market. There are some like Doc, Matter, or Microsoft Entra Verified ID. The one I showed you was Entra Verified ID. But those are the solutions you can use to issue and verify verifiable credentials. So with those solutions, you can configure everything. You will have dedicated apps, and you can manage those credentials. And some of the companies, like OutZero, for instance, is working on this interoperability. So they also have like cool demos that, for instance, you have verifiable credential issued by Entra Verified ID, but you want to verify this in Matter, and like different kinds of mixes. But the case is that there are concrete implementations in the market already. So obviously, if you are interested in implementing something on your own, you can do it. There are standards I showed you, but also there are those solutions available on the market. Yeah. So I did my best to provide you with many different details, and I hope that you enjoyed this session and this information. And if you have any questions, I'm open to that, as I mentioned. I hope that I have answer for you. So thank you so much, and yeah, please provide your questions. Thank you. Thank you so much. Yes, please.
In the case of a malicious user that has access to the digital wallet, is it possible for the issuer to revoke the public key in the data registry?
That's a very good question. Yes. So let's talk about a few concepts here. So first of all, short answer, yes, you can revoke credential. So there are, again, when it comes to standards, different implementations. But the case is that like typical scenario, like for instance in Entra, is that you are creating index on one of the claims within your credential. Let's say it's your unique ID or email, and it's hashed. And basically it lands on some list. I don't want to dive into technical details, but basically when the verifier is doing the verification, it can check basically like, hey, is this credential still valid? So because there can be situations like, let's say, you're employee of some company, but then you are not this employee anymore. Yes, you changed the company. So just to summarize, yes, you can revoke credential, and also credentials have their own expiry date that can be set. Any other questions? So last thing I want to add to that, you can revoke credentials, but also what you can do, you can back up those credentials. Yes, so in case that, I don't know, like you lost your phone, whatever, you can export those credentials, and then using another, let's say, device like this, you can retrieve them. Yes, because of the fact that the private key and everything what is related to holder is placed here on this device. So basically you can export this, and without any problems you can move those credentials to other devices. But the case is that credentials are not transferable, okay? So it's not like I can share my credential with my colleague and this colleague can start using it. Nothing like this. Like it's not about NFTs or any other technology. Yeah. Any other questions? Yeah, sorry, yeah. Mm-hmm.
Maybe I just lost a little bit with Vasily, but what happens with the, so you verify the credential with the application. What happens then with the credentials that you share with the existing web browsers? Are they storing, meanwhile you have a session, and when you log out, that's just disappear, or what happens after with those, with this information?
Okay, so I will rephrase just to make sure that I understood, and let's dive into this question. So you are asking about the situation where I was signing into the application, I presented my credential, application accessed and established the session, and now what's happening with this data? Yeah, good question, thank you for that. So first of all, underneath we have again standards. So when it comes to application session, in the end application will receive ID token with all the claims that were taken from the verifiable credential, okay? And now, obviously, if this session will expire or token will expire, that's done. However, when it comes to, like access to this data that you shared, application has access to that. Like if you decided to share your first name, last name, and all other details without using selective disclosure, I mentioned, then application has access to that. So what application will do underneath, that's under the risk. Like application can, like take your address that you shared and can do some different things, okay? So in this specific example, once you decide to share your credential, you have no control over the claims you shared. And that's why we have this selective disclosure, which is currently implemented, at least in this solution I showed you, to make sure that in the end you can only like share the minimum amount of data. That's how it is. Yeah, thank you. Any other questions? Okay, so again, thank you so much, and have a great rest of the day. I hope to see you during some next sessions in the future. Thanks.